Welcome everyone. I see everyone's coming in. So as everybody is starting to come in, I'm gonna start off with the introductions. First of all, thank you so much everybody for being here. We really appreciate you coming every week. For those of you who are new, the Grand Rapids 2030 District does a cannabis webinar every week to help you on the topics that you have voiced your interest in. So if there's further curiosities on topics you want to hear more about, things that you need to be clarified, shoot me an email, Jillian@USGBC-WM.org, and we'll make sure to get an expert in front of you, all right? So because of the curiosity from our members, we are talking about comparing HPS to LED side by side. And actually, a perfect case study happened here in Michigan at Adrian location for Fluresh. So we have Scott to talk about why they chose LED. And we have Brady also to be able to explain the intricacies of it, and Rachel to talk about how you can get a little incentive. So I'm sorry, Brady, can you go back 1 second? Thanks so much. So a few little housekeepings before we begin. Remember, there's a Q&A and a chat. Chat if you want to just chat the panelists, if you want to chat just the moderator, if you want to chat everybody, be aware of who you're sending it to. And the Q&A, like send your questions in the Q&A. As soon as you have a curiosity, put them in. We're really curious about what you have to say. Be a different box, right? And one more thing is that there's going to be a survey coming at the end. Make sure you fill it out because that shows us what you thought about this webinar and what more webinars you want to see. So now, Brady, may you please shift over? Thank you so much. So I'm Jillian Gim. I'm the program manager for the 2030 district. And we have the speakers, Scott Asiala, and he is the vice president of cultivation and extraction for Fluresh. And we have Brady Nemeth. He is the utility rebate coordinator for Fluence Bioengineering. And lastly, Rachel Fredrickson. She's the indoor agriculture specialist for consumers energy. And the three together will have a really dynamic conversation about how to save yourself money from a budgeting perspective in the long run, how to make better crops for yourself, as well as how to get a bonus check, just cash, straight for doing good energy efficiency. So without further ado, I'm going to turn over to Brady, our industry expert, to talk about, but before you don't go anywhere, folks, because the 2030 district has a Grand Rapids Cannabis Energy Management Best Practices Guide for you. This is based on specifically the zoning, the ordinance, and the best practices that Grand Rapids wants to see you guys pay and lead them. So read it up. It's on our website, and if you want to know more, let me know what you think, and we'll be able to provide that for you. So now, Brady, may you please begin?
Awesome. Thanks, Jillian. So as she mentioned, my name is Brady Nemeth. I'm the utility rebate coordinator at Fluence Bioengineering. We're a commercial lighting manufacturer in the horticultural space. Fair warning now, I'm not a photobiologist. First couple of slides will give you a little bit of background just to make sure everyone's kind of working from the same set of understanding there. But then I think more importantly, Jillian mentioned, it's awesome to have Scott and Fluresh involved here because we get to talk about real world actual projects. So we have a couple of lighting designs to go through, and so I'll get started. First thing that's kind of really most important to know is anyone who comes from the traditional C&I, commercial industrial lighting world, probably used to talking lumens and watts, more specifically lumens, as far as luminaires go and how much light is coming out of the fixture. In our world, we're talking about PAR, photosynthetically active radiation. That is kind of industry standard right now, defined as between 400 and 700 nanometers. There's lots of discussion about expanding the PAR range. There's other things that can be achieved on the plant side of things in far reds, which is kind of that 700 to 750 range, or even things like infrared or UV on the other end. So nonetheless, that is the kind of main metric that everyone's looking at, 400 to 700. Notably, it's kind of exactly the same as lighting for the human eye. But how do we go and use that metric of PAR. So first is PPF, that's photosynthetic photon flux. That is sort of the measurement of how much is coming out of the luminaire. While that's important when making a lighting choice, that's really only looking at it from the product level, which isn't really all you need to look at. You need to look at what's it going to be like when it's installed on a specific project. So then you're going to turn to things like PPFD or perhaps DLI if we're growing in a greenhouse scenario, doing some supplemental lighting. PPFD, you can think of as sort of equivalent to foot candles if you're familiar with it. So it's how many of those photons are reaching the plant canopy or at a given surface. PPFD is measured in micromoles per meter squared per second. So it's kind of, again, a measurement of intensity where you actually want it, because you could have the greatest fixture in the world that has tons of PPF, but if it's in the wrong application, you know, growers really care about how much of that light is reaching my plant canopy. DLI is daily light integral. It's another concept. It's basically PPFD, but over a day. And so if you were using to supplement natural lighting, for instance, a greenhouse scenario, you might have a target DLI of, in a veg space, maybe 35 or something like that. And the more intensity, it's just basically a product of the intensity of light and the time, the photo period. Spectrum, I have another slide in just a second that will go over that a little bit more, but obviously when it comes to LED, there's a lot more we can do in terms of research around spectra and things like that. Whereas in the HPS or in the legacy world, you're a little bit more hemmed in there. Efficacy is pretty much the same. Again, other than lumens per watt, you're dealing in micromoles per joule. And to give you a rough idea, the most efficient sort of legacy technology out there is probably double-ended HPS. And those are probably going to be somewhere around 1.6 to 1.7 micromoles per joule. The DLC, if you're familiar with it, again, from the commercial industrial lighting world, they have a minimum requirement for LED of 1.9, but really anywhere in the 2 to 3 range is probably going to be most common for LED, and we'll probably just continue to see that increase. And then form factor, I'll talk about that a little bit more. So Jillian mentioned something like this might be helpful. So in the background, we have Fluence's, one of our main spectrum, the Physiospec indoor, and we sort of compared it here to both high pressure sodium that you see in yellow. You see a lot of that, the oranges, ambers, yellows. Obviously, that's kind of what you see too when you're underneath those lights. And then CMH, ceramic metal halide in black, you can see favors a little bit more towards the end of the spectrum and some of the far reds. Then in the pink, we also listed out narrowband LED. That's sort of like what's I've heard referred to as like blurple, kind of like the early on LED where you had a lot of blue and red, blue and purplish light, where they kind of picked out two ranges of the spectrum that they thought were most useful for photosynthesis in the plant, but we've sort of have a greater understanding now that there's a lot more that light can do for the plant outside of those narrow bands. Again, I'm not a photobiologist, so I'll kind of leave it there. I will say Fluence has some really good resources. We have a photobiology guide and a cultivation guide, specifically for cultivating under high intensity LED lighting. Cannabis loves light and can take a whole lot of it. So that presents some of its own challenges, CO2 supplementation and things like that. So I'd really recommend that you go and check those out. If you do have any more photobiology questions I can't answer, I'm happy to put you sort of in touch with someone who's far smarter than I. But I'm going to jump right into sort of one of the later projects that I've seen come across my desk for Scott and his team at Fluresh. So I'll just scoot forward and then back up just a second. I'm going to show you a couple of comparative designs between some flower rooms, some veg rooms, and I think a mom room as well. I'm going to back up and just note about the form factor here. This is our Viper 2P. This is what Scott's gone with in some of the flower rooms. The reason it's actually built like this is actually more for a greenhouse application to be hung underneath trusses with sort of minimal shading. But the design is just as good for indoor as well. Typically, you're going to see it whenever you have a single rack and not a tiered system. And when we get into one of the tiered rooms, the veg room, I'll show you the form factor for that. Again, you can see we can offer a different spectrum in this, and again, just some high-level specifications so you can sort of, wrap your head around those numbers. So this is something that actually we produce for people like Rachel and utilities, so that we can kind of claim the energy savings that Scott or any of our customers are saving by going well and above what is sort of common industry practice. So in this case, we modeled one of these flower rooms with both 1,000-watt double-ended HPS as well as our Viper 2P. And what we always try to do is we always try to match that PPFD within reason. So we want to make sure that the intensity of the light at the canopy level is going to be more or less equivalent to show, hey, we're not giving you guys throwing you for a loop, trying to way overlight the space or anything. These are comparable examples. So this is what they would go with. It's a no doubt cheaper option up front, but it's a lot more expensive OpEx for sure. So again, you can see in their flower room, these two designs had a PPFD of about 900. That's pretty fairly common, higher hundreds for flowering rooms. And again, just sort of running through the comparison. These are super easy because these are more or less one-to-one, one-to-one fixtures. So it's not really a ton to look through there. Here's another flower room, same sort of thing, just different shape where we're, again, one-to-one, and the PPFD is about the same. Next was the veg room. So one of the things you'll notice about these is they've moved into now a tiered rack scenario. So one of the benefits of LED is the form factor and how you can fit it in much closer to the canopy. So in this case, we have a couple of different options. The kind of standard ones, that 47-inch or nominally 4 foot, covers 16 square feet of canopy, which is pretty industry standard there. The fixture, even with the driver, you're only looking at a couple inches of thickness there. And this is our 2X. It's for veg, so the light levels are a little bit lower than they would be for flower, but let's take a look at that. So they've got actually have two different fixtures in here. Again, form factor with LED, you can really accommodate what the customer needs. So they had two different size racks in here. What we compared it to was basically a whole lot of T5 high output lamps, which is a legacy technology that can be used in its place. And I have an energy savings summary that I'll show you in just a minute to show the impact that this all has. And then lastly, there's the mom room, Viper 2X, kind of the cute little version of the Viper 2P. You notice the output, the PPF before is about 1700. This one moves down to an output of about 900. As such, the wattage goes down as well. And all these, I forgot to mention, all these are DLC listed. So again, if you're familiar with the commercial industrial lighting space, DLC, they have a qualified products list. That makes verifying their performance kind of easy for everyone, the customer, but particularly the utility as well. So in the mom room, despite the fact that's a separate fixture, real easy one-to-one replacement. Only difference is we modeled against a single-ended HPS because the output was going to be lower than the double-ended. And you notice in the mom room, again, that PPFD average is going to be a little bit lower because they're growing in the space for a different purpose. So what does all that look like? That's an overall annual kilowatt hours saved of about 1.4 million kilowatt hours, which is equivalent to the consumption from about 126 average American homes each year. So that's just the sort of electricity costs that they don't have to pay. But thankfully, because of programs like Consumers Energy have, they have other opportunities to reduce their costs through an incentive as well. So I'll let Scott and Rachel talk about that a little bit more. That's all for me for now. My contact information is up there, and I will pass it along to Scott.
Thanks, Brady. So while Brady unshares his screen, we'll be able to see all four of us for a little minute. And at this point, we're going to be talking to the grower himself on what was enticing about an LED versus HPS. To give the audience a little bit of background, I'm sure Scott will speak more on it. You had an amazing location at Adrian, Scott, where you did a side-by-side comparison of HPS and LED. And if I recall correctly, the next installation that you did was completely LED because you were taking it upon yourself to have a comparison. So this is a very unique situation in what I know of all of Michigan. And we'd love to hear your particular story on that as well. Would you like to explain what made Fluresh interested in it? And you're still on mute, by the way.
Can you hear me now?
Yes, thank you.
Okay, good. Thanks. So when we started designing, so the Adrian campus is large. It's a 30 acre facility down there. Currently has about 75,000 square foot gross in the greenhouses. So there's roughly 57,000 square feet of cannabis down there being grown. We have in north of 12,000 plants at any given time in the greenhouses. And then through production, we'll run about 46,000 cannabis plants will be harvested they're all veg and flowered under LED. So it's quite a large facility. We've got quite a large volume of plants. We did start out, as you touched on, kind of some of that legacy stuff. We looked at, the HPS, ceramic metal halides. We looked at double-ended. And it kind of, some of the things we looked at down there is we did a hybrid model. So we have light-up greenhouses. So we're utilizing the natural sun. And then as Brady touched, we're doing the kind of supplement and the PPFD with the Fluence or with the LED lights. Some of the things we were able to achieve that we couldn't do, so I'll give you an example, like in one of those rooms down there, we have rooms that, we have par meters, so as the plants grow from, early veg to late veg, early flower, and all the way to harvest, we actually ramp up our PPFD and our par. So we can get as high as 1,000 in those rooms, which is, without mechanical air conditioning. Basically, there's evaporative cooling systems in these, what they call a pad wall. There's no way we could achieve those light levels with HPS. I mean, it would literally be an oven in there. So we have about 158 fixtures per room, and we target to say as high as 1,000 par in the PPFD on 90% of our canopy down there. Some of the things that we noticed, comparing the two, there's one thing that a lot of people don't factor in is the bulb replacement. So with Fluence, we got a 5-year warranty on basically the drivers and the diodes, and then I think they're IP67 or 66. So you can. I mean, I don't recommend this, but you can basically spray them down and wash them down because we do fog and foam the rooms after harvest. So that's a big one. Where if anybody that's worked with HPS or ceramic halide or the double-ended, if you get one drop of water on there, the bulbs actually explode. It's kind of a fire hazard. So a lot of that you don't have with the Fluence. So bulb replacement was a big one. Typically, you would, in a grow of this size, with dedicated flower rooms, you would, replace those HPS, whether single or double-ended. You probably replace them about twice a year. They degrade very fast. Where with the LEDs, it's less than 1% degrade over a year. So we run the same fixtures, and I think, on everything, the spec sheets on our particular generation, we really aren't going to see any degrading of the diodes for about 7 years. So that's a huge cost savings that a lot of people don't factor in. Okay.
Yeah, thank you. A question that came to mind when we were thinking about your perspective, and honestly, Scott, you just had so much information at once. I'm really glad there's a recording so I can go back and learn in detail what you were speaking about. So you were talking a little bit about having to adjust other factors. You had said in HPS, if you had it all in HPS, that it'd be an oven there, right? So how do you adjust your HVAC and other systems differently according to which lighting technology you use? I feel sometimes that is a detail that people have to learn a little bit down the pathway, but it seems more about that, about what other systems to
Oh, I lost her a bit at the end there.
Yeah, we got a big delay. Can you still hear me?
Yep, can hear you, Scott.
Can you hear me?
Yeah,
Can you-
I think Gillian, the big
Oh my
the big
God.
you know the big thing is that we have different. So we run these LEDs in our Adrian facility, which is a very large greenhouse. And then we also have our Grand Rapids location, which we just basically moved plants in about a month ago, and that's an all indoor 210,000 square foot facility up there. And again, you know, that's that's all air conditioned. So those are what you call closed agricultural, perfect rooms, sealed rooms, lots of different, you know, terms for it. But essentially it's a room kind of like behind Brady and his backdrop where there's really no exchange with air. So you're not bringing in outside air. You're not exchanging air. You're elevating your CO2 levels in that room. And basically the whole room is a conditioned space with HVAC. And it's a night and day difference on the tonnage. I won't go too much into that, but you know, a lot of these rooms, I'll just throw some numbers out there. A room where, say, we, you know, on HPS, we were going to need 100 tons of HVAC, where with Fluence or with an LED, you can almost cut it in half or even lower than half because you don't get the heat. And then on the AC side of things, when you want to take and go vertical, which we've done in our Grand Rapids location, because of the less amount of heat, I can get the plants a lot closer and allows us to do those the 2-tier and the triple tier stacking. It allows you to basically take a room maybe where you could do 1,000 veg plants, and now you can do 3,000 veg plants because you can get the plant much closer to the fixture without the added heat or the stress on the plant. So there's a lot of advantages from the heat side and then the HVAC side of things, both I would say from a greenhouse perspective and an indoor warehouse.
Thank you, Scott. Can you hear me all, everybody?
Yeah.
Okay, thank you. Despite you not hearing my full question, I think you answered it completely. So thank you, Scott. So, so lastly, you're talking about not only are you able to pack in more plants because the place is not so hot because you're using a superior bulb LED, but also it seems to be a big money saver too from an operations perspective, correct? And could you speak to what you saw differently in operational cost from using LEDs versus a different light? And that'll be a good segue to talk to Rachel.
Yeah, I think the big obvious one is just kilowatts, right? I mean, the power meter's running, you're using power. You know, when you're flowering plants, the lights are on for 12 hours on, 12 hours off. I mean, you can go, you know, there are modifications to that light schedule. And then, as probably everybody on the call knows, you know, a mother plant, a veg plant, you know, that's under typically an 18/6 where your lights are on, you know, 18 and then off for 6. And then some cloning and even some veg programs I've seen, they actually run the cannabis under 24-hour light. So it's really a big savings on the electrical side. The cost there, again, that it compounds because of the efficiencies on you can go with the smaller HVAC systems, or you can even move to what we've done in Adrian, where we've got we've got indoor lighting levels. As you know, we get a lot of snow in the winter, so we can keep a 1,000 par all the way through these polar vortex snowstorms. And then even in the summertime, you know, if it's raining, if it's gloomy out, we're still able to do that all without basically having any kind of mechanical cooling other than evaporative cooling pad walls. A couple other things I want to touch on really quick, and then we'll hand it off to Rachel. Some of the other benefits that we have done in-house, we've done lots of testing. We, you know, as you know, in Michigan, you only can do a 15-pound batch of cannabis, and then it's a package tag, and it has to be tested. We harvest twice a week at our Adrian location. So we've done thousands and thousands of tests. But some of the other nice things that it's helped us with in our production model is we're able to create what we call flex rooms because we can veg. Essentially, we run our mothers, our clones, and everything under full spectrum lighting which is a lot different than what you've seen in the past. So a lot of times in the past, you would have a dedicated room where you would veg under, say, like a metal halide, and then you'd switch to a flower room with an HPS, whether it's single or double-ended. Where with us, we actually, we call flex rooms, where we veg and we flower under the same light, whether that's a Fluence down in, in Adrian, we use what they call the greenhouse Physiopes. And then in Grand Rapids, we use what they call their indoor, which is more of a full spectrum with the blues and everything, because you're not getting the natural sunlight. So I think that's been a big thing for our production model, is being able to create flex rooms where we can veg and flower if needed under the same fixture. So it's really helped out the production model as far as, dedicated rooms. With previous older technology, you would have to convert the room over or do a fixture change out. So it gives a lot of flexibility from that aspect too.
Wow, that's incredible. And there's actually been some questions that have come on since you've been talking, Scott. So I'm gonna bounce over these questions real quick. So Elise asks, how did you see any difference in the plant yield or quality when going from HPS to LED?
No, we're hitting, we're in a greenhouse. We've had labs come in as high as 25% higher down there. I think a lot of it, I know there's a lot of focus on, yield on HPS versus, ceramic metal halide and LED and full spectrum and not full spectrum. But I think there's a lot of other things that factor in. Lighting is one of them. But I think, environmental, I think BPD, CO2, nutrition plans, IPM, pest pressures. All of those things factor in. But no, we've run, like I say, we'll run 46,000 plus plants this year under this 100% LED facility. And it's, we're building out in Grand Rapids, we're building out more facilities in Adrian, and everything that we have seen, the benefits far outweigh any of the negatives. We haven't had any negatives that I would say that would say we're not going to continue to do this. So everything has been very positive.
Wow, that's amazing. That's a big testament, especially since I've talked to some folks who are diehard HPS fans, and ever to each their own. Honestly, it seems that you're really convinced from the technology that you've been working with right now. And actually,
and I would just add, there's different, you get what you pay for, and that holds true in the lighting world. Fluence is a very expensive light. It's a very high-end product. It's not, it's not a knockoff LED that's coming from, say, overseas. So I think the quality of the diodes and the lighting layouts, there's a lot of things that factor into being successful. And they do the lighting layouts. They've been a good partner, but I think there's a lot of things that will factor into the yield and making sure you hit those numbers that you're looking for when you go into the design phase of your, greenhouse, your hybrid greenhouse, or your indoor grow,
Exactly. So, Elise, I know you heard that question. If there's a follow-up that you want to do, please feel free. Jamie asks just a question just now. She said, quote, "You said you've done a large amount of testing. I'm curious to what fidelity? By that, I mean to ask if you've got a thorough side-by-side of the cannabinoid and terrapin profiles, HID versus LED."
Yeah, we do terp profiles. So again, we get kind of, in Adrian, they're getting natural sunlight and we're supplementing down there. So a lot of time in the summer, you're going to get more of the time where these lights are dimmed down. They may only be running at like, say 15% or 20%. And the plants are getting a lot of the natural light coming through. Another thing we did down there is we upgraded our glass. So you can do a lot of different ways to design a greenhouse. You can do it like a poly. I find that the poly almost immediately starts to yellow and starts to degrade versus, the glass. You get more of the sun to come in. Then you can do a diffuser glass. That's the route we went. And then in the summer, moving into the winter time, we get a lot less light. We're doing a lot more supplement with the LEDs. Terp profiles look good. We've got terp studies on plants, mother plants, and genetics that will run, indoors and warehouses anywhere from they were under, T5s to HPS or ceramic metal halide. It flowered under HPS. The terp profiles look good. I think our terp profiles even look a little bit better in Adrian probably because we have the full spectrum and we're getting some of that natural sunlight versus when you move indoors 100%, you're not getting any of the natural, lighting that comes from the sun. And it's hard to, we do our best, but nobody can replicate the, Mother Nature and the sun.
Amen. Amen, Scott. So something had come in a little earlier. It's a bit of a quicker question. How long does it take to replace your bulbs? A whole day? Probably referring to when you're replacing a whole room, I assume.
Yeah, so we have a very tight production schedule. So our rooms are, they're only down for less than 24. It's, at a big facility like this, it's a nightmare because you got rolling benches, you have, you've got fire suppression, you got video cameras, we've got, what am I looking for the word here? Air purification system. So there's a lot going on in the ceiling of one of these large grow rooms. So it is a pain. I mean, it would probably take, in the stuff that we did, I would say it's a good extra 6 hours that room is going to be out of commission by the time you get everybody in there. You take down the bulbs and then you replace the bulbs, refire a room, make sure all the bulbs are firing. And then there's the other side of it is the disposal of those bulbs. Because they do have that arc tube with the hazardous gases in there, so you do have to take them to an approved facility to dispose of the bulbs. So all that factors in with the LEDs. We're able to go in, we can fog the room, we can foam the rooms, we can even wash the fixtures off because they are, that IP66. So it's a time-saving deal all around when you do that. Say, some of these rooms are harvested 5.5, 6 times a year. It really factors in on how fast you can reset the rooms.
Correct. So folks, there's these 2 other questions coming up, and I think they're more, looking at the timestamp, they came in when Brady came through. So from you folks on the call, would you rather take these questions at the very end after Rachel's done presenting, or Brady, do you want to answer your questions right now?
There are 2 quick ones I can take and be pretty brief about.
Sure. Can you read
the first one? What's that?
Can you read them aloud? Because I think that only we can see the Q&A.
Yeah. So the first one was asking about the average PPE or efficacy of other technologies such as the HPS or ceramic metal halide or fluorescent. Typically, the highest, again, any legacy non-LED technology is going to get. It's probably going to be about 1.7, maybe 1.8 if they're doing something really sort of extraordinary or different. But fluorescent, you could be looking all the way down to 1 micromole per joule. So it's a quite considerable difference. We just, for what it's worth, our newest products, our newest spectra, some of which are not fully broad spectrum, but they're up in the 3 range. A lot of it is still in that mid 2, 2.5 to 2.7, just to give some sort of scale. The other one was, why would someone choose 1-to-1 if the results aren't that, if things weren't different? So one thing I should say is that comparison was done in this case, essentially for a utility incentive. And I believe those were all new construction. Scott, correct me if I'm wrong. So oftentimes in retrofit scenarios where they have existing HPS in there, we're almost always raising the light levels because we can to essentially no detriment, right? They've already installed an HVAC system that's designed to handle the load of a room full of HPS. So we can actually increase and give higher light levels. Very oftentimes our retrofit customers desire that increase. In this case, we're doing it backwards a bit. We had already modeled according to the customer's need, according to their PPFD, and then we went back and modeled, okay, what would this same request be from the customer if we were giving them a legacy lighting solution? Sorry, one more came in. I'll stop there after this, and then Rachel can get her turn. What's the warranty of the LED fixtures, and what's the expected life of LED versus HPS? So Scott sort of mentioned on the HPS side, you said you might be replacing it once or twice a year, the bulb, and that doesn't include the how often you might need to change the ballast on the HPS. HPS, I mean, no doubt, it's sort of a proven technology from the regular human lighting side of things. But LED, rather than, if you're familiar with the concept of in traditional lighting, where that is the lumen degradation. It slowly degrades over time, and they're looking at L90, and because there's no catastrophic failures with LED, like there is an incandescent bulb where something pops and it's done, right? You might have that with LED, but it would be out of the ordinary, and that would be a problem with the fixture. But because growers are so much more sensitive to light and that light output, it's actually bumped up to what they call Q90. So it's determined to essentially have gone through its useful life after it's at 90% of initial photon output. For what it's worth, the DLC says that, you know, they set requirements, and usually their requirement is 36,000 hours or greater at L90, but all of ours are well over 50,000 hours of use. So definitely lifetime is a big one. And Scott highlighted not only the cost of lamp replacement, but also all the labor, as he mentioned, in disposal costs that go into it. So that's it, or that's all I see on there. So I guess we can go on.
That's what I see too. And Tony, thanks for the question. If you got a follow-up question, please feel free to pop it in. So Rach, could you fill us in on, from the utility perspective, what your folks are trying to do to help the cannabis industry?
Absolutely. Let me just get this going. So hi, my name's Rachel. I work for Consumers Energy in the Business Energy Efficiency Program. I am their indoor agriculture specialist. So we offer a very nice incentive, I think, for LED grow lights. In order for the lights to qualify, they just need to meet 4 factors. So they need to have a power factor of at least 0.9 or better. They need to have a rated lifetime of at least 50,000 hours. They need to have a 5-year warranty, and they need to be either UL or ETL listed. So if the fixtures meet those qualifications, then they will qualify for an incentive. So how we do new construction versus retrofit is just a little different. It's the same incentive amount per watt reduced, which I'll explain in a second. It just changes the type of paperwork that we need. So for a retrofit facility, what we do is we look at the current lighting system that you have. So how many fixtures, what's the wattage? We put that in the pre. And then for the post section, we look at what you're going to. So how many LED lighting fixtures are you going to have? And what is the wattage of the LED fixtures? It then subtracts from each other, and you get 70 cents for every watt that you reduce between the 2 systems. So if you're going from a 1,000 watt HPS to like a 600 watt LED, that's around $300 per fixture, which can be, you know, very helpful since LEDs tend to be more expensive than the HPS, obviously, but they've definitely been coming down in price, which is great. And then how we do the new construction is what Brady was showing earlier. So typically for new construction, we have to look at building code. And as you guys are probably very well aware, there is no building code for grow lights in indoor grow facilities. So what we kind of have to do is we look at the fixture that you want to install, and then we look at what that would be comparable to. And to make sure that the fixtures actually are comparable to one another, we require them to have relative PPFD levels, just to make sure that you're receiving the same light output and that your plants aren't going to suffer, or to make sure that people aren't being outrageous in saying that they would be installing like 100 HPS versus the 20 LEDs that they're doing instead. And to just keep everything, you know, as honest and uniformed as possible. So once again, we look at what the fixtures would have been on the HPS or T5 side, and then what you're actually going to be installing, and you get 70 cents for every watt that's reduced between those 2 systems for new construction. So you might be wondering, how do you actually qualify to receive this incentive on the customer side? So the first thing is you have to be a Consumers Energy customer. If you're not a Consumers Energy customer, don't let that stop you from trying to receive a rebate. A lot of utilities in Michigan offer incentives for energy efficiency products, so please reach out to them to find out if they offer anything for your grow lights. You have to have a federal tax ID number, so you must be a business. So sorry to any of the caregivers out there. I would love to work with you, but this program is for the commercial growers. And then if you are a new construction customer, that's great. We'll definitely still take you. We just need you to be a Consumers Energy customer by the time you turn your building on. So what is the application process? First, we check to make sure that you're a Consumers customer, or that you're going to be. Then you're going to submit your pre-notification. And what the pre-notification basically is hi, this is my name, this is my address, this is what I want to do. I then am going to review your application, make sure what you're doing actually qualifies for an incentive. And assuming that it does, I will then reserve those funds for you. So we take that money, we set it off to the side, it now has your name on it, and we're ready for you to do your project. So then you're going to do your build and install your equipment. Once everything is installed, you submit your final application. And the final application is just a signature saying, hey, my lights are complete, along with the invoices to show that you purchased what you said you were going to purchase. Now, if your incentive amount is over $50,000, then a final inspection is required, where we come and do a walkthrough of the facility to make sure that everything is actually installed. And then once we do that, I submit your application for payment, and it takes about 4 to 6 weeks for you to physically receive the check in the mail. So this is where you're going to find our application, consumersenergy.com/start savings. You can also find some other useful tools here. This is if you haven't decided which contractor you're working with yet, or you don't really know how to select a contractor or anything, we have this nifty Find a Contractor tool. And everyone who is a part of that contractor tool is also a part of our Trade Ally network. And so basically what the Trade Allies are there are different contractors and suppliers that have come and been trained by Consumers Energy on how to use the program. One of the nice things about the Trade Ally program as well is they are often very familiar and accepting of our third-party payment release. So you can make an arrangement with your contractor where the incentive check will go directly to them instead of to yourself, and that this makes it so your upfront cost, you already have the incentive amount taken out, so it's just cheaper for you to, won't have that large upfront cost. So it's just a great resource to help you get started if you need help selecting one. Now, if you are doing a project and you're not using one of our Trade Allies, that is 100% okay. It is not a requirement to be using them in order to apply for the program. So if you're using someone who's not listed, that's fine. Please still send me your project information, and I would be more than happy to work with whoever you are working with. So I just wanted to touch on some of our successes that we've had with the program. We gave T-Rex Enterprise $121,000 last year for their new facility. And then of course we have to have Fluresh in here as well. They received almost $250,000 for this incentive. And I just want to point out that this was only one of their phases. I believe we're more in the $800,000 range now for total incentives. So, this is real cash money. I encourage everyone to utilize the program as much as possible. And I'm more than willing to go through spec sheets, let you know if things qualify, how much your incentive would be. And also, I always want to point out that we offer way more than just lighting incentives. We'll take a look at your HVAC, dehumidification. If you're doing edibles, we'll look at your kitchen equipment. So we have a very wide range. So if you're deciding not to go LED, we still might have incentives for you anyways. So
thanks, Rachel.
Yeah.
Sorry, was there some final thoughts? I didn't mean to cut you off, but that was just so fun to listen to.
Yeah, nope, I was just saying, and now we're to our questions.
For sure. Oh my gosh. I really didn't know about the kitchen incentives that I should have really thought of that about that, especially because I work with restaurants who get rebates from me all the time for their kitchen equipment. So we actually have a question right about your incentives from Deborah. It says, are the controls incentives in the grow side the same as the CNI side?
So the controls are a little bit more difficult, unfortunately, for the growing side. So if we're talking lighting controls, then yes, they're all the same. If we're talking HVAC controls, then it gets a little bit tricky because of a lot of our HVAC controls are based off of CO2 levels. And as you can imagine, your guys' CO2 levels are way above the normal. So it's made it kind of very difficult for us to incentivize HVAC controls. But if you're doing lighting controls, we got you.
I'm just typing an answer to Deborah real quick. Okay. So another question had come through. Are there residential rebates that could benefit the caregivers?
So not for grow lighting, unfortunately. We do have a residential program where you're able to receive incentives for if you get a new furnace or new air conditioning, or if you are installing like screw-in LED light bulbs and stuff like that, but nothing for the grow lights, sadly.
For what it's worth, that's unfortunately, it's pretty uncommon right now across all of North America for the residential market. We just started a program that's sort of a pilot in Oregon where they're doing an upfront discount for residential customers, but it's extremely rare. I think Vermont is the only, Efficiency Vermont, I think, has a program. So hopefully our utilities will see this start to play out for residential customers because there's a lot of savings there as well.
A curious question. Do you anticipate that like changing like throughout the years as cannabis becomes more of a nationwide normal thing?
Once it becomes federally legalized, I think a lot more people will be open to residential programs. But until that happens, I don't really see it changing.
Okay. Would you say that too, Brady?
Sorry, my mute button was stuck. Yeah, I would agree. And luckily, Rachel's program is like absolutely fantastic. She's great to work with, and not all programs are like that. And they have some other challenges with cannabis still being federally illegal. There's other sometimes things such as on-bill financing or kind of financing through the utility that you can't do because the bank that they would use is a FDIC insured, and therefore they can't touch cannabis even though it's legal in their state. So there's all sorts of, I mean, I've certainly seen all of the red tape that cannabis growers have to deal with, and it's certainly no exception here. But the consumers program, all of them in Michigan have been very good to work with. So,
for sure. I'm tempted to go down that rabbit hole a bit more, but I need to stick to the questions that have come in already. Maybe we'll have another talk on that particular topic. So for folks on the call, you can always send in your Q&A or chat like right there on your screen. Also though that you have the opportunity to send in what we call early bird questions ahead of time, so that this gives the speakers a bit of knowledge about the curiosities you have and the ability to tailor their message to fit what you want to know. So there's actually a particular question that came in from James, and this is a question that I've been kind of curious about too, on like about a cogen approach, and I know sometimes there's only so much we can do when we're working straight with utilities, but if we're thinking from an overall creative perspective, he asks, how familiar is everyone with CHP or cogen on cannabis? I know that some upfront cost capitals of CHP can be a hurdle, but CHP plus LED is about 20% of the energy cost as compared to a grid plus HPS. The industry standards overall the industry standards for all large greenhouses in Canada and Europe are using HPS. For those, CHP, combined heat and power, for folks who want to know the acronym on the phone. So now knowing what James has been curious about, could maybe Brady, maybe Rachel, Scott, talk a little bit about how cogen connects into this?
Sure. So on a personal level, I think cogen is, fantastic, especially when, depending on where you're located, the grid might physically not be able to support your power needs. Especially if you go out into the rural areas where it's just not really suited for three-phase out there. So cogen is definitely a way to go if that's one of the problems. The downside of cogen on the utility standpoint is it then makes your project extremely difficult to incentivize. So our incentive program is, you kind of buy into the incentive program. If you look on your bill, you're going to see like a small little charge that everyone receives, and that's what fuels our energy efficiency program. And so if you're not using our energy, then you're not buying into the program as much as a person who, is completely on our grid. And so it makes it so we're not able to incentivize you to the fullest that we would like to be able to. So it kind of just depends on, your self-preference on, are the incentives like important for you to receive versus like the overall total savings of using the CHP versus completely on the grid. Because right now in Michigan, natural gas is significantly cheaper than electricity, but is that going to be how it is for forever? I don't know. So right now it's a very nice, suitable option, but if that continues is anyone's guess.
For sure. And Brady, from a from an engineering perspective, do you have thoughts on that?
Sorry to burst your bubble. I'm not an engineer either. I'm just a very.
Oh, my bad.
No, but to Rachel's point, different utilities have different motivations. So I've actually seen it kind of split 50-50. Actually, it's probably not exactly 50-50, but there are some, if a utility is super concerned about like peak demand and like meeting that, they'll actually sometimes incentivize a cogen plant to go in the first place. I know we have a customer I've worked pretty closely with in Ontario where that's the case. Massive cogen plant that they use to heat all their greenhouses and provide CO2 as well. But it is a vast majority of the time, yes, they say, well, you're not even really pulling that much power from the grid, therefore you're not really helping us, because people are, they're ultimately incentivizing it because they're basically purchasing energy savings back from you. So if you're already off the grid or close to it, then they say, there's nothing for us to do here. But there can sometimes be other incentives out there. It just depends on the utility. So always ask the utility.
For sure. Thanks, Brady. My first exposure with CHP probably was in undergrad, but our college was heating and producing electricity, but based off our Willow project. We had like a Willow biomass project as a part of a research project that we were doing on campus. So I guess, folks, I know that sometimes it's difficult to find ways to properly dispose of the rest of the cannabis plant, right? Maybe you could just put it into CHP and see what happens, right? So there's a question that had come through from the Q&A. And I think this question had come based on the timestamp, probably when you were talking, Rachel. It says, how does an LED plus consumer's buy down compare price-wise to HPS price without a consumer's buy down? Do you know that answer?
I can give you some rough estimates. So I've been kind of keeping track on my own end on how much our incentive actually will cover people's fixtures costs for the LEDs. So I've been finding that with our incentive, we're covering about 20 to 35, 40% of the actual fixture cost, which is really significant, especially for these
Yeah.
more expensive fixtures. So your LED, depending on what kind of fixture you're going to be buying, is probably going to be anywhere from, $600 to $1,200. And then on the opposite end, your HPS are probably going to be around the $150 to $300 range. So the incentive really does make them very comparable. And then once you have the energy savings, your payback is going to be so short. We're talking about 1 to 3 years. So if you're planning on still being operational in 1 to 3 years, which I hope all of you are, it's 100% worth it cost-wise.
That's a great note to leave on. Thank you, Rachel. So folks on the call, we're ending the end of the hour. So take down these information if you want to get a hold of Rachel or myself. And thank you, Scott and Brady, for being a part of the call. Could you go to the next slide, please, Rachel? Yep. So just a reminder, everybody, there's going to be a survey coming out at the end of the, after this webinar. And it's going to be asking you what your takeaways from this webinar was and what more you want to see. And that fuels a lot of our choices when we're finding experts to speak on this matter. So please fill it out. It's very important to us. Now we have coming up tweaking the margins, how controls set you up for a better yield and a leaner operation budget. That's this time next week. We're really excited about that one. That one's going to be a really good one. So please tune in next week. And thank you, everybody, for coming today. And thank you, our visionary supporters as well. But lastly, thank you, Brady, Scott, and Rachel, for taking your time out of your day to speak with our members. We really appreciate your time and your expertise on the matter. And I hope to be talking to you guys soon.
Thank you.
Thanks.
And so we'll see you guys next week. Thank you, everybody.